complete the third lesson. We are dealing that lesson with work, energy and power. Okay, tell me what is that work? When the external force is act on the object, when the object is displaced from one position to another position, then there is some work is done by that force, then it is called work done. Okay, so work done, after that, what is the energy? The capacity or ability to do that work, we need some energy, internal energy or maybe external energy, whatever may be. Okay, some energy only you can do that work, so that it is called energy. So both work and energy have the same dimension, then also they have the same SI unit, joule or Newton's meter. Okay, now what is that energy? Energy is the ability to do the work. There are the two type of energy, one is the potential energy and another one is kinetic energy. Then what is the relation between work and kinetic energy? Okay, the work done is nothing but what? Rate of change of is kinetic energy. Rate of change of is kinetic energy. Okay, now we are going to deal with that topic, elastic potential energy. Elastic potential energy. When just think about that. If you have the spring on your hand, okay, when you are pulling out that spring outward, one end is fixed, okay, and one end is fixed with that on. When you pull out that spring outside, what will happen? Its elongations, okay, it will be elongated like this. So maybe this displays with some distance x. Okay, now whenever you are applying the forces here, which is acting away from that, when you release the force, when there is no force, again it forms to the original state of our original length. Okay, there is a deforming or it is come back to restoring forces. Okay, restoring forces will be acting on that one, so it's come back to the original strength length, and that force we called as spring force or what is that? Elastic potential energy. That energy only gives some that force. So when the spring is elongated, develop the restoring force. That restoring force, the potential energy possessed by the spring due to the deforming force which stretches or compresses the string, it terms elastic potential energy. Okay, normally that elastic spring force, okay, when you are doing the acceleration of force will be the opposite direction of this spring force. Always the opposite direction of the spring force. Okay, then Fs will be equal to minus Kx minus Ks. The spring force is negative sign. The negative signs always indicates the spring force always opposite to the displacement. Opposite to the displacement. Okay, usually we know that U equal to FDR cos theta. Okay, now we can take that this one f dx, okay, because of dx is formations. Now f dx, when theta equal to 0, cos 0 will be equal to 1 from the position 0 to x, 0 to x. So what is the f? Fs will be equal to minus kx. Okay, or else you can take this in the plus kx. So kx dx, integration 0 to x. So what will happen? When you are doing the integrations, then it will become x squared by 2. Okay, k x squared by 2, 0 to x, upper limit minus lower limit, also you will get u equal to 1 by 2 kx squared. So this is how the elastic potential energy stored in the spring. Okay, if suppose from the initial position xi to xf changes like that, then it will become 1 by 2 k xf square minus xi the square. xf square minus the final position minus initial position. Okay, now what will happen if that potential energy and displacement graph on the spring? So whenever the potential energy is maximum, kinetic energy will be 0. Kinetic energy will be 0. Okay, so now I can write this graph. I will draw this graph. Okay, for this one we have the potential energy and then kinetic energy. Okay, so whenever the total energy of the system, whenever the kinetic energy will goes like this, the potential energy will be flow like this. Okay, so potential energy will be go like this. Okay, so now if you consider this one is kinetic energy and this one is potential energy, what will happen? Whenever the potential energy is 0, kinetic energy will be maximum. Whenever the kinetic energy maximum, potential energy will be 0. At the center, at the middle of the point, both potential energy and kinetic energy, sum of the total energy will be equal to both kinetic energy and potential energy. Okay, delta change in the kinetic energy will be equal to change in the potential energy. Change in the potential energy. Conservative forces or non-conservative forces. What is meant by conservative forces? Conservative forces is nothing but we are taking the forces, okay, the force have to be considered as the work done against the forces when we are taking the initial and final position of the particle, okay. After the force given to the particle, we are taking the work done by the particle from the initial and final position, not considering about the path of that force, okay, not depend upon the nature of the path followed between the initial and final position. Suppose if you are doing the particle moves from here to here in this direction, okay, we not to take all the path followed by this particle. We can take the initial and final position of the particle, then it is said to be the conservative forces. For example, in the gravitational force is a conservative forces, okay. The object is falling from the height of the building to the ground, okay. Where due to the gravitational forces, the object falling in this vertical direction. We need not to take all the paths developed by this object. We can take only the height of the object. That means is the initial and final position of the object. Then it is said to be the conservative forces. So example for the conservative forces: elastic spring forces, electrostatic forces, magnetic forces, and gravitational forces. Okay. What is mean by non-conservative forces? What is mean by non-conservative forces? The conservative forces work done by or against that particle. The conservative forces are non-conservative forces work done by or against the forces moving the body depends upon the path followed by the particle. We have to take what are the forces or what are the work is done by the particle, not only the initial and final position of the particle, also we have to take what are the distances covered, how much of forces is given throughout the path, throughout the position, initial, in between that initial and final position. Okay, the frictional forces. When the object moves from here to here, there must be a frictional forces acting. Okay, so we have to take the frictional forces. The object is moving from here to here, then also we have to take the frictional forces. So the frictional forces are non-conservative forces. Frictional forces is a good example for non-conservative forces. And then the force due to the air resistance, viscous force also non-conservative forces. We are not only taking that initial and final position of the particle, also we are taking that path followed by that particle. Path followed by that particle. Okay. What is meant by law of conservation of energy? Law of conservation of energy. We know that the energy neither be created nor be destroyed. Okay, it can be transformed from one form to another form. Energy neither be created nor destroyed, but it can be transformed from one form of energy into another form of energy. Okay, whenever you are dropping that stone or when you are dropping the ball from the height of the building, what will happen? When you are dropping some object from the height of the building, here it has the more risk. You are considering you are throwing some objects towards the sky. Okay, you are giving them some energies. The kinetic energy, whole kinetic energy is converted into that potential energy at one point, and it takes rest at the fraction of second. After that, what will happen? That potential energy again is converted into the kinetic energy. Again, you come back to that ground state with that maximum energy. After that, you stop with that potential energy. Okay. Okay. Now, what will happen when you are dropping that ball? There must be a potential energy. This will be converted into the kinetic energy, and then it will come back to the original state of the potential energy. So the energy can be transformed from one form to another form, but it cannot be destroyed. Okay. Now look at the page number 184. Then look at when there is a maximum U equal to mgh, equal to mgh, kinetic energy will be equal to 0. Then total energy of the system will be equal to potential energy. At the midpoint of the both potential energy is not equal to 0, kinetic energy is not equal to 0. So total energy will be equal to kinetic, sum of the potential energy and kinetic energy. And then ground state, reach the ground, potential energy will be equal to 0, kinetic energy will be equal to maximum. Kinetic energy will be equal to maximum. Okay, so the total energy of the system will be equal to kinetic energy. Total energy of the energy will be equal to kinetic energy. Okay, now this is one of the question, two more question. Law of conservation of energy states that energy can neither be created nor destroyed. It may be transformed from one form to another, but the total energy of an isolated system remains constant. Okay, the next one, motion of the vertical object. Okay, vertical Motion in a vertical circle. Motion in a vertical circle. Consider an object revolve around the earth or something, whatever may be. Imagine the body of the mass attached to the one string, and it is taking the circular path. Okay, it is taking the circular path. Here we have the object. Okay, we have the stone from the center. From the center, stone is attached, so the tension is acting in this direction. So normally we have the two tensions which is acting in this direction. So here m perpendicularly mg cos theta will be acting. Here we can take that mg. So mg is acting, the downward gravitation force is acting. So normal force will be acting in this direction. So mg is not only the mg, it's nothing but your parallel component mg sin theta. Mg sin theta. Here I have the tension forces which is acting towards the center O. Which is acting towards the center O. Okay. This is with nothing but your radius of the circle. Radius of the circle. Okay. Let's make an angle. Mg cos theta and mg is make an angle of theta. Now we have to calculate what is that, how much of work done, or what is the velocity of minimum particle to move from here to here. Okay. So first, think about that. Imagine that body mass is attached to the one end of the massless and inextensible string, executed in the circular motion. Executed in the circular motion in a vertical plane, with the other end of the string is fixed. Let us consider the motion of the body taking the gravitational forces which is acting downward direction, tension along the string. Okay, so the radial or whatever taking, the tension is aligned along this towards the center, and the mg cos theta is acting away from the center. Okay, so the mg sin theta parallel component, there are two parallel components. In the tangential side, in the tangential direction, at this direction, what are the forces? Mg sin theta acting in this direction. The normal forces will be acting on the opposite directions. Okay, so we can write mg sin theta in the tangential position. Okay, mg sin theta will be equal to normal forces, nothing but ma. In the tangential force MAT. Okay, and Newton's nothing but mass into acceleration. Now we can write mg sin theta will be equal to mass into acceleration. We can write rate of change of velocity. Rate of change of velocity. But here the acceleration, tangential retardation. So tangential acceleration is acting opposite direction. So we can take as in the negative sign. We can take as in the negative sign. Now, what will happen in the radial direction? Radial direction in this direction. It is called radial direction. So, in the radial direction, tension, okay, tension and the mg cos theta is in the negative direction. Okay, mg cos theta, which will be equal to the force which is acting in the radial. Okay, in the radial direction. MAR. So, mass into acceleration in the radial direction. So what will happen? That radial direction is nothing but rate of change of centripetal acceleration, right? So it's acting towards the center. So acceleration we can take as t minus mg cos theta, which will be m. Here we have the minus, okay, because minus b square by r, it is a centripetal acceleration. Centripetal acceleration. Okay. Now that tension acceleration is acting towards the center, so we can take as the positive. So mv squared by r. Now we can take out what is the masses. The mass is having the tangential acceleration g sin theta for all the values except the theta equal to 0 degree. It is clear that the vertical circular motion is not a uniform motion, and velocity is not constant in the course of motion. The tension in the string also is not constant. Tension in the string also not constant. Okay, so this is the one of the formula, and equation t equal to the tension will be equal to what will happen? Mv square by r plus mg cos theta. Mg cos theta. So t equal to mg cos theta plus mv square by r highlights the section A and D. Mg cos theta always greater than 0, hence tension cannot vanish even the velocity vanishes. Okay. The mv square by r equal to t minus mg cos theta. The second term is always greater than 0, hence velocities cannot vanish even the tension vanishes. Okay, even though the tension is not there, the velocity will not be vanishes. Now, what will happen at the lowest point? Okay, we have to find what is the tension along the points. So, what will happen to the lowest point? Now, we can change this one, the formula. First, initial position. consider initially the object will be here. Okay, this is a question of 1, this is a question of 2, bottom and upward direction. Here we have the velocity v1, here we have the velocity v2, which is acting in this direction and which is acting in that direction. Here I have that one, okay, mg, which is acting in these downward directions. Here r, here r. Okay, total distance covered by 2r. Total distance covered by that object 2r. Okay. Tension which is acting in this direction. Tension 1 will be acting in this direction. Okay. At this point, when the particle or when the object is coming here, the tension will be acting in this direction and mg also acting in this direction. Now, what will happen for the lowest point? What will happen to the lowest point? Now, look at the picture. T1 is acting in these y directions and mg is acting in the opposite direction. So, T1 minus mg will be equal to centrifugal forces. Okay, a centrifugal acceleration. What will happen? M v1 squared by r. v1 squared by r. Okay, in case of T1, what is the T1? T1 will be equal to mv1 squared by r plus mg. This is one of the equation. The second one, for the highest point, at here, Tr and both having T2 plus mg will be equal to, both are acting in the same direction, so positive, mv2 squared by r, mv2 squared by r. So then T2 will be equal to mv2 squared by r minus mg. Now, what we have to do? T1 minus T2 from the equation. T1 is greater than the T2, so T1 minus T2. T1 minus T2 will be equal to, what is the T1? mv1 squared by r plus mg, okay, minus mv2 squared by r minus mg. When you are multiplying the minus, it will become minus and it will become plus. Okay, then mv1 squared by r minus mv2 squared by r plus 2mg. Take that m by r outside. M by r v1 squared minus v2 squared plus 2mg. So this one t1 minus t2. This one is t1 minus t2. Now we have to calculate what is that v1 square and what is that v2 square. What is the v1 square and what is the v2 square? The total energy of the system will be equal. The total energy for the bottom and the top of the surface, the total energy of the system will be equal. So we can take that sum of the potentials at the lowest point. Okay, what is that? T1 minus T2 will be equal to m by r v1 square minus v2 square plus 2mg. This is one of the tension force which is acting on the directions. Now we have to take the potential energy at the point 1. From here we have the potential energy. At this point we have the kinetic energy. Okay. So at this point here the total energy of system will be equal to potential energy. So U will be equal to, at this point will be equal to, potential energy will be equal to 0, and here we can take as kinetic energy will be equal to 0. So the total energy of the system, what will happen at point 1? At point 1. So here that at the point 1, U equal to 0. Kinetic energy will be equal to half m v1 square. Half m v1 square. Because we have to give this some force, right? Kinetic energy will be given. So the total energy will be equal to E will be equal to U plus kinetic energy. So potential energy plus kinetic energy. So half m v1 square. Okay. At the point 2, at the top. Okay. At the point 2, potential energy at the point 2 equal to 2mg. Okay. Potential energy at the point 2 here mg, h is nothing but r plus r, so it is 2r, mg 2r. Kinetic energy will become 0. Kinetic energy will become 0. No. Kinetic energy also will be there 1 by 2 mv2 square, because v2 is there, right? So mv2 square. So what is the total energy? Total energy will be equal to mg 2r plus 1 by 2 mv2 square. mv2 square. The total energy at the point E2. At the total point at the E2. So equating these two forces, E1 will be equal to E2, right? So half mv1 square will be equal to mg2r plus half mv2 square. Take the half, okay? Half will be cancelled, mm will be cancelled, right? So we can take that one, 1 by 2m, 1 by 2m, v1 square minus v2 square, okay? Take this one side, 1 by 2m, v1 square minus v2 square will be equal to mg2r, okay? mm will be cancelled, r2 will be goes there, so what will happen? v1 square minus v2 square will be equal to 4gr. v1 square will be equal to 4gr. Substituting there, t1 minus t2 will be equal to m by r 4gr, because of v1 square minus v2 square equal to 4gr plus 2mg. r will be cancelled. 4mg plus 2mg, 6mg. t1 minus t2 will be equal to 6mg. t1 minus t2 will be equal to 6mg. At the minimum speed of the highest point. What are the minimum speed required at this point? What will happen? So the tension must be equal to, tension T2 will be equal to 0. From the equation T2 equal to what? What we have get? T2 will be equal to mv squared by r minus mg. Here the tension will be equal to 0. So mv squared by r will be equal to mg. mm will be cancelled. So v squared will be equal to rg, right? So v2 square. So v2 square will be equal to rg. Then v2 square will be equal to root rg. v2 will be equal to root rg. Substituting here, v1 square minus rg will be equal to 4gr. Then v1 square will be equal to 4gr plus gr will be equal to 5gr. So v1 will be equal to root 5gr. Okay, minimum speed, which is velocity, which is needed at this point, okay, at this here is root 5gr. Okay, the minimum speed which is we needed, okay, the body must be have the speed at the point v1. v1 must be equal to root 5gr or greater than the root 5gr. Then to stay in the circular path, or otherwise it cannot be stay in that circular path. It will be collapsed. Okay, so this is a very important one question. And also we will write one thing, power. What is mean by power? Power is nothing but rate of work done per unit time. Rate of work done per unit time. So what is mean by rate of work done per unit time? Okay, so the power is a scalar quantity. It is a dimensions will be equal to ml square t power minus q. Okay, so power is the unit of power is watt, because the names after that the who's the discoverer or founder of the steam engine, James Clerk Watt. James Watt. Okay, so what is mean by 1 kilowatt? 1 watt is nothing but 1 joule of work is done by 1 second. Then it is called 1 watt. The 1 horsepower equal to 746 watt. 1 horsepower equal to 746 watts. Okay, so 1 kilowatt hour equal to, you know all those things. 1 kilowatt hour equal to 1 into 10 power 3 into 36 into 10 power 3. Sorry, 36,000 seconds. Okay, so what happened? 36 into 10 power 5 joules. Okay, so this is 1 kilowatt hour. Now listen. So guys, please take care. Please aware of this. We will continue with this class. Okay, inshallah. Next session we will take this power and all those things. Be ready for your examinations. Do it well. Okay. Don't skip any questions from there, and then don't skip any examinations for October month and November month test. Okay. Thank you guys. Allah Hafiz.